Welcome everyone to another presentation up to the time. Today we are going to be looking at trochoids. So let's get into this. Now, what is a trochoid in technical drawing? It is a curve traced out by a point fixed to a circle where the point may be on, inside, or outside the circle as it rolls along a straight line. So there are two types of trochoids. There's an inferior trochoid and then there's a superior trochoid. Today we'll be focusing on inferior trochoid. So what is an inferior trochoid? An inferior trochoid is the path or locus of a point which lies on the inside of a circle when it rotates along a straight line without slipping. So let's look at some examples here. So the top example, let me take out my annotation so that we can all see properly. This top example here, which I'm focusing on, this is an inferior trochoid, right? Because this marks a point on the inside of the circle. And you can see how this path moves. The curve never goes outside the circle. That's the one thing we can take away from this inferior trochoid. And now let's look at the normal cycloid. The normal cycloid is when the point is on the edge of the circle. So you see how it moves? Like that. That's a normal cycloid. But what we are focusing on today is an inferior trochoid. Now let's look lastly at the superior trochoid and see how this moves. So I will highlight this in green. This is when the point is outside the circle. So as it rotates, the point is always outside the circle. And the path is always outside the circle. So that would be a superior trochoid. But just to focus our minds today, we are looking at this. So this is the curve that we should be plotting today. All right. Without any further ado, let's get out of here and get back to the inferior trochoid. So I have the steps here, and I have the problem, and I also have introduced something called visual steps, as we can see down here at the bottom. So let us go through the problem first before we get into the steps. So what does the problem say? Draw a locus of a point 7 millimeters inside the periphery of a circle which rolls on a straight line path. Take the circle diameter as 56 millimeters. Place a tangent onto the curve at a random point M. Okay. So the first thing, we need to set this up. Let's start with what we know. We know that this is going to be rolling on a circle of diameter 56 millimeters. So let's create that. So I'm come here to the right, C for circle, and then I create a circle. And I'm in the radius mode, but I want to switch over to diameter. So I'm going to press D while I'm in the circle option. Enter. And then I'm going to type 56. So that's 56 millimeters there as my circle. Now, I need the line which the circle is going to be rolling on. And the line is going to be the distance of the circumference of this circle. So a circle that is 56 millimeters. Let's see how we can find the circumference of the circle. I'm going to show you all without doing any calculations. So you highlight the circle, then you right click onto the circle and you go to properties. So the properties here, it gives us the radius, which is 28 millimeters. It gives us the diameter, which is 56 millimeters. And it gives us the circumference, which is 176 millimeters. And it also gives us the area of the circle too. But what we are interested in here is the circumference. 176 millimeters. So we can use this information, draw a line at the base of the circle and pull it to the right and make it 176 millimeters. Okay, so that's our circumference there, locked in. Now, so we got the circle and we got the path which it's rolling on, which is the circumference. The next thing now, what we need to do is we need to create the inner circle. Okay, so the information here tells us that our inner circle is drawn at a locus of a 0.7 millimeters inside of this circle. So what I'm going to do, I'm going to offset 7 millimeters. So this represents our inner circle. All right. So let's label these circles. So I'm going to label the center of my circle as point O. And I'm going to label this first circle as point E. And the second circle as R. So we always know what we're referencing when you say O to P is this circle, and O to R means the larger circle. Okay, so we've labeled the circles. Now, what's the first step we need to do in solving this problem? The first step is we need to divide the circle. And down here, I have already highlighted the steps, so I can go through them quickly so that we all know what's going on, right? So this is the first step. So I will put step 1 here, first step. First step, we go ahead and divide circle into 12 equal parts. That's the first step. The second step is we divide the line here, which is the circumference line, into the same 12 equal parts. So that's the second step. And then the third step, from our circle, we need to create horizontal lines from the divisions of the circle. And these will be done at the third step. So these are the 3 major steps that we need to complete before we even attempt solving this problem. All right. So let's go over to this circle here, and I'm going to divide this now. So I select here the circle, type div. That's the command to divide anything. And I divide, I touch the circle, and I hit 12. And I see my 12 divisions. Now, if you're doing this for the first time and you don't see your 12 divisions when you divide the circle, that means that you do not have your point expression turned on. So let's do that now. Let me at least show you how to do that. Type P, type. P, type. P represents point, and we are actually looking to assign a point type or a point style. So we come into this point style menu. You choose any expression. Select the size that is comfortable for you to see this expression on the screen. I normally select size 1, and I go to set size in absolute units, and then hit OK. And that's my size, and that's what it will look like. Okay. So now I'm going to set up my crosshair. So I'm not going to put all the divisions in the circle. I'm just going to set up these 2. And I'm going to place this into my center layer. Yeah. And this will be placed into my center layer because these are the centers. Now, so I've divided my circle into 12. The next thing now is I need to divide my circumference R. So let's call this R to S. R to S. I divide this into 12, div. Select here, type 12. And the divisions are there. Now what I'm going to do is I'm going to project lines from RS up to O, the halfway line. So I'm going to project one line. And then I'm going to copy this multiple times. So I go copy, CO is the command to copy. I select the line, one click, and then I'm going to go into my array mode. So I'm going to specify second point or array. I go array, then I type 12. It's the number of divisions, number of lines that I want to be on. All right. So I've gotten that. That's in. That looks good. Now I'm projecting lines from the circle right here, going through these points. So as you can see, each line goes through 2 points on the circle. So this will go through point 11 and point 1. And I'm going to this down to 10 and 2. This goes through 8 and 4. This goes through 7 and 5. And then this one goes through 6 by itself. And this goes through 12 at the point here. For those probably wondering what I'm talking about, these are the points I'm referencing, these numbers here. I would actually just transfer these numbers over to the circle that I'm working with for educational purposes, right? I'm just going to copy. All right, so you see, those are the numbers on the circle. And I'm going to do the same thing for these divisions here. You know what? I should have placed the divisions at the top. So I'm going to do this again. So right now I'm just transferring these numbers from this baseline, and they would appear here. Okay, good. So everything is set up. The circumference line, R to S, has been divided. The circle has been divided, and the number that both of these lines have been divided is 12. So everything has been divided into 12 segments. Okay. So we now need to roll the circle. And the circle that is being rolled is the inner circle. So this point P here is what we are interested in finding as it rotates. So let me just put a point there. And I'm going to put that point into outline because that's going to be a point that I'm going to be plotting to form this curve. So let's move this circle now. So I'm going to move from 0 . Just make sure that I'm doing this correctly. No, I made one mistake. The circle that needs to be divided is the inner circle because that's the circle that's being rolled, not the outer circle. So let me just correct this error. So I divide the inner circle, the outer circle. So I've divided now the inner circle. And these numbers would correspond to these inner points. 12 would be at the top, 1 would be here, 2 would be there, 3, and so forth. All right? No. So we have our first point P here. Now let's move this circle. Needs to be there. That's where 1 needs to be. And now let's move to 2. 2 needs to be here. Let's move now to 3. And 3 would be right here. All right. So that means if we move to 4, 4 will be right here. Here. And that means if we move to 5, 5 would be right here. And if we move to 6, 6 would be at the top. And then once we get to 6, we can actually mirror the rest. So I'm going to do that. I'm going to turn off the construction. And let us just let me remove that. And let me just start to put this into a spline. But before we do that, let's select these points. So this is point 1, 2. So this will be point 0, 1, 2, 3, 4, 5, 6. These are our 6 points here. I'm going to mirror these so that we can get the other 6 points going down to create the full curve. So we have all 12 points in now. Let's SPL and connect these. 1, 2, 3, 4. We are halfway, and then we go down now. 7, 8, 9, 10, 11, 12. And this curve is called an inferior trochoid. Yeah. So now let us turn back on the construction layer and look at this. So I'm going to leave this circle here so that we can all understand how the circle rolls, but I'm going to put it back here where it originally belongs. And what I'm going to do is I'm going to transfer the numbering over to the smaller circle so that this would all make sense when we look at this. Because it's really the smaller circle that we divided. The bigger circle was divided as a mistake. So trying to correct my mistake now before I actually close this video. But for all intents and purposes, the trochoid is finished. Now, after I have cleaned up this bit, I'll be placing a tangent onto the trochoid. So I'm going to be placing a tangent from any random point. Yeah. And removing these points that aren't necessary any longer. Okay, I think I've done that. So far this looks good. This looks really good. Let us know. Hold on, I need this line here. This line here is important. And this line here, we will put that in that. Next thing now, I'm going to place the dimension here, which is my circumference. I'm going to also dimension my circle. So the inner circle is 21 and the outer circle is radius 28. All right. Now, the last thing now is we now need to place a tangent. This is what we are going to do. Place a tangent and the normal at some random point, M. Now I'm going to choose a point on the right-hand side. I'm going to probably choose a point on the left-hand side so that we all can see how this works. So I'm going to randomly choose a point, and I'm going to choose right here. So this is my random point, point M. This is where I'm going to create my tangent. So what's the first thing I need to do? So I've selected my point where I want the tangent to be. The next thing is I'm going to take the rolling circle and put the axis of the rolling circle at point M. So this is the rolling circle, put the axis there at point M. And let's see what happens. It cuts the line, the halfway line at 2 points. Point here and a point there. Now, I'm going to use the point between 4 to 5. So I put a point there, and let's call that, well, if that's M, let's call this N. So this is point N. And then at point N, what we do is we take a line and go straight down to the baseline and create a perpendicular, right? And from that perpendicular point, we then connect to M. That goes all the way back to M. So first, we locate where M is, where we want to put this point on the curve. From there, we take the axis of the rolling circle, which is at radius 21, and we place the axis directly on M. This would allow us to cut a point on the halfway line. It cuts 2 points. We observe 1 point. I observe the point which is between 4 and 5. Where it cuts, I create a point there called an N. And from N, we go all the way down to the baseline, create a perpendicular. So I'm going to identify this as a perpendicular, which is 90 degrees. Right? So that's your perpendicular. And from that point there, so I can call this point Q. And from point Q, we set up a diagonal line from Q all the way to M. Now this there is our normal. Right? This represents the normal. Now what we are going to do is create the tangent. So once we've found the normal, it's fairly easy to create the tangent. We just need a perpendicular line from the normal. So let's do that now. So what I'm going to do is I'm just going to move this circle here. I'm going to create a smaller circle right there, and then I'm going to trim. So this circle represents 360 degrees. What we are looking for is 90 degrees. So I'm going to trim this circle. So right now, it now represents 180 degrees, which is half of 360. But again, what we are looking for is 90 degrees. So we need to divide this in half. So I'm going to find the halfway point here, midpoint, and pull it back here. And now I have found my midpoint. And that means this line is the properties of this line represents the tangent that I'm looking to find. So I'm going to extend this line. So that we can see the line properly. Then I'm going to label this as my tangent. Okay, so I've gotten my tangent and I got my normal installed. So I'm just brightening the layers. So this is my normal and this is my tangent. All right. So now let us just place the label on them. So it's tangent, and I'm going to rotate this. So I hit R to rotate, take off my ortho, and I just rotate that like that. I know it's not rotated as neat, but I'm just going to do that and leave it for now. And I'm just going to put in the word normal now. Normal. Rotate this as well. So this is my tangent and my normal to my curve. And the curve created is called an inferior trochoid. Right? So I think I've done everything for this particular problem. I've answered the question. The question asks to draw a locus of a 0.7 millimeters inside the periphery of a circle which rolls on a straight line path. Take the circle diameter as 56 millimeters. Place a tangent onto the curve at a random point M. I have done that. I have created the inferior trochoid curve. I've placed the tangent and I've also placed the normal. And in doing so, I have shown you all my working. So nothing should be a mystery as to how I got this done. All right. So now I'm just cleaning up the drawing before I'm about to close. So just before we close, let's review what we did today. We actually we focus on a topic called inferior trochoids. But first, I explained what a trochoid is as it relates to technical drawing. Then I went into explaining what an inferior trochoid is. I answered the problem, I've gone through the steps, and I have created a tangent to the inferior trochoid. Again, I would encourage everyone, if you don't understand this video, digest it in steps. Take small baby steps. You can stop, pause the video, rewind. You might have to write down some of these steps, or you might just have to keep practicing to make sure you understand these steps properly. Whatever you do whatever is necessary to make sure that you understand this work. All right. The next video that I'll be doing in this trochoid series would be a superior trochoid. So folks, please look out for that sometime soon. It was nice being here. Don't forget to like, share, and subscribe to the channel. I am out. Thank you.